Good morning. This is my video submission for the end semester examination. This video will answer the first question of that set that we have gotten out of 6 questions. That is. So the question states that there is a vessel containing 20,000 cubic feet of air, and the vessel receives an inflow of 600 cubic feet of fresh air and a simultaneous outflow of 600 cubic feet per minute of air that is made a uniform inside the vessel. So we need to find the amount of fresh air at time t and the time it takes for the vessel to attain 90% purity of fresh air, that is. So I've written the differential rate of change of the fresh air as the difference of the inflow and the outflow that the vessel gets. So mathematically writing this, we can get just a minute here. 600, this is a constant because the inflows does not change, minus 600 parts, that is the amount of air flowing out, upon the overall volume of the vessel times the amount of fresh air already present. So this will become our non-homogeneous linear first order ODE that we will solve to eventually get the value of y with respect to time. So this becomes our rather pt, and this becomes our qt. So the solution for a non-homogeneous first order linear ODE generally follows a template, which is, I would express it as this, where the IF stands for integrating factor, which is written as dx. So the variable, I mean, you can change the reference for integration. So my x changes to a t. You will see later on. So putting, or rather, first I'll find the integrating factor here. So in this question, the integrating factor will be just a minute. So 600 by 20,000 t will be our integrating factor. So putting all the parameters in the expression that we have attained, we will get something. Oh, I'm sorry, just a minute. The integrating factor exponentiates this function. Just a minute. I'm so sorry about this. Just a minute. This is our correct. Where C is the constant of proportionality that we need to add. So solving the integrand on the right hand side, we'll find out that this is there. This is how it goes. So I will sort of send the integrating factor over the right hand side so that we can isolate yt in the left hand side itself. So we get something of this sort after sending my if to the right hand side. This is the solution that we get. So this is the general solution of the differential equation that we received. So the initial conditions said that we did not have fresh air at time t is equal to 0. So I did not write this, but it's understood that y at 0 is 0. So putting t is equal to 0, we can just a minute, I'll do it there. So on my next page, at t is equal to 0, we can get, the reason I am doing this is because the exponent contains a factor of t as well. So since t is 0, the exponent becomes 0, so this becomes 1. So we get this expression. So c becomes minus of 20,000, which happens to be the next expression that we are using. So putting c is equal to minus 20,000 in the original expression, we can get y of t is equal to 20,000 minus e to the power minus 600 by 20,000 into t. So this is the solution that we receive for the non-homogeneous linear first order ODE that we obtain. So the amount of fresh air at any instant of time is this. Now for the second part, they specified that the purity at that given time is 90%. So that is 0.9 times the amount of fresh air at infinity, which is the theoretical value that it attains. Now I can write this as something of this kind here. We can just use this. So taking natural log on both sides and sort of taking this to the left hand side, so that I can get t in the left hand side. We get this t minus 1 times 2.303. Now this factor comes because of the conversion between log to the base e and log to the base 10. So we need to multiply it with an additional factor of 2.303. So we cut this and we get time is equal to 2.303 times 20,000 by 600. Cutting this out, we get 460.6 by 6, which can be approximated to 76.7 minutes. So this is my solution for the second part, and that should be the end of the first question. So this expression is the relation between the amount of fresh air at given time t and time, and this is the amount of time it takes for the mixture to become 90% pure. I would also plot this before we end this video. This should attain a theoretical value of 20,000 at some instant. that is for YT and time. All right. Thank you for your time. Bye. Okay, just for the record, I did this.